Hi, I'm Austin. Me and Eric are doing rocks, and I'm doing the topic portion. Rocks. There are three main types of rocks, and these are igneous, sedimentary, and metamorphic rocks. Igneous rocks are basically rocks that are a solidified form of magma. Sedimentary rocks are called secondary rocks because they are often the result of accumulation of small pieces of broken pre-existing rocks. Lastly, metamorphic rocks are rocks that change in form by heat and pressure. What's the chemistry involved? The chemistry involved in igneous rocks are less interested in the minerals that might have formed where there or whether the rock is glossy or fine grained, and also classified in acidic, intermediate, basic, and ultra basic. Sedimentary rocks are composing in the carbonate rocks and called calcite (CaCO3) and dolomite (MgCaCO3). Calcite is called limestone and contains with fossils. And also the sedimentary rocks, in contrast to carbonate rocks, are deposited by chemical precipitation. Metamorphic rocks determine the composition of the parent rock. The low metamorphic grade, low temperatures and pressures, about 200 degrees Celsius, and the metamorphic grade of 800 degrees Celsius version on melting, such as genesis and mingamite, and have a high temperature and high pressure phase, solomonite. Rocks made up the minerals matter of soil used in sand, silt, and clay. The chemical formula for one chunk of rock can be majorly different than the different chunk of rock, even though they were both broken off from the same outcrop. Rocks are any mineral that form an essential part of the earth. And here's a rock diagram of an igneous rock forming, like, it's in volcanoes, and then it forms into like a sedimentary rocks when you see in sand in the mountains, and then it turns to like a metamorphic rock. One is just when you see rocks like every day. And here's a example of like a picture of calcite, limestone, and then here's an igneous rock, and then here's a metamorphic rock.
Alright, Austin did the topic part, so I'm going to go over the career, which is geologists. Geologists don't only study rocks, they also study the earth as a solid, its rocks and its minerals. Geologists can predict almost any major destruction before it even happens, like maybe hurricanes, earthquakes, tornadoes, all that. Geology also includes paleontology, which is the study of fossils, and fossils are just rocks that used to be bones. What it takes to be a geologist, or the background you need to be to be a successful geologist, you need to have a high school diploma with the recommended classes of geology, geography, and math, including algebra, trigonometry, and statistics. You also need a college education, and you need to be physically fit, because this guy is up in the mountains recording all this stuff and hiking around all day. You have to be fit, and then you also want to have good time management. What chemistry is involved? Geologists use chemistry when understanding how rocks are formed and what they are made out of. One very important application to chemistry that they use is to interpret the chemical composition of carbonate rocks. Limestone and dolomite rocks are very important also for oil and gas reservoirs, but they difference by only one substitution of a single molecule. And limestone is CaCO3, and dolomite is only MgCO3, and they have to use sophisticated measurements to find the difference in these two. And then for salaries for geologists, with a bachelor's degree, they can expect to get anywhere from $45,000 to $50,000 a year. And then for a master's degree, they can expect anywhere from $50,000 to $55,000 a year. But a geologist with 20 years of experience can easily make over $100,000 a year. And then for the picture, we have a carbonate, which it has to do with the origins of ocean water or water, and then the dolomite rock, which is to do with the oil and gas reservoirs. So that's our project. Right?
Yep.